Welcome to Mathmerge. Now that I have gone through what are multiples and factors of a number and tests of divisibility, I come to the next concept, that is of prime and composite numbers. Also, I will list down the prime numbers less than 50 and I will cover square root test to find if a number is prime or composite. Any number having no other factor other than 1 and itself is a prime number. Others are composite numbers. So any number which has a factor other than 1 and itself is a composite number. This is the difference between a prime and a composite number. 42 is a number. I can say 2 is a factor, 3 is a factor, 1 is a factor, and 42 also is a factor. So other than 1 and itself, it has 2 and 3 as factors and many more factors. So that is why it is composite. Whereas the number 17 has no other factor other than 1 and itself. So it is prime. The number 1 has only one factor, that is itself. So it is neither prime nor composite. Whereas 2 is the only even prime. All other prime numbers are odd numbers. I will list down the prime numbers less than 50. So the examples of prime numbers I will just list down 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, then 32, 33, 34, 35, 36 are all composite. 37 is prime. 41 is prime. 43, 47 is prime. And after 47, there is no prime number less than 50. So these are the prime numbers up till the number 50. And these have no other factor other than 1 and the number itself. It is easy if the numbers are below 50 to find if the number is prime or composite. But if I have a larger number, is there a simple shortcut way to find if it is prime or composite? How to find if a large number is prime or composite? I can find out that using the square root test. So first I find an approximate square root of the number. If the number is a perfect square, then of course it has an exact square root. If it is not a perfect square, then I find an approximate square root. And till that square root, I've list down all the primes less than that square root. If any of the prime numbers can divide that number exactly, then it is a composite number, otherwise it is prime. Say I have a number 49. I know this is a perfect square and 7 is its square root. I can write the factors of 49 are 149 and I can write 49 as 7 times 7. So 7 is a factor of 49 and if multiplied with like in a pair, then I get the product as 49. Similarly, for other numbers also, factors occur in pairs. One would be small and other one larger. Consider the number 441. It is a perfect square and its square root is 21. So I can write 441 as 21 times 21. And since the square root is 21, I list down all the prime numbers less than 21. So all the prime numbers less than 21 are 3, 5, 7, 11, 13 and 19. If 441 has a factor, like say 3 is a factor of 441. If I divide 441 by 3, the answer will be 147. Let me check. 441 divided by 3, the answer is yes, 147. So if I have a prime number which is a factor of 441, which is the prime number less than its square root, then the other factor will be greater than its square root. They will occur in pairs. One will be less than the square root and one will be greater than the square root. So I can also write 441 equals 3 times 147. So one is less than the square root, other is greater than the square root. It is not possible that both the factors are more than the square root. Else I will get a number more than 441. So I can take the square root as a marker and check if any one of the prime numbers below the square root divides 441. Say I have 7 divides 441 exactly. So 441 divided by 7 equals, no, it equals 63. So 63 times 7 equals 441. So since a prime number less than the square root divides 441, so it is a composite number, not a prime number. Now similarly, if I have a number which is not a perfect square, I find an approximate square root and check if any of the primes below this approximate square root exactly divide it, then it is a composite number. And if it is not divisible by any of the primes less than the approximate square root, then it is a prime number. Say I have a number 72 and it is not a perfect square, but it is between two perfect squares, that is 64 and 81. Square root of 64 is 8 and square root of 81 is 9. So here this approximate square root of 72 is between 8 and 9. So the prime numbers below 8 are 3, 5 and 7. And when I divide 72, 3, 5 and 7 and also 2. 2 is also a prime number less than 8. And here also, here 21, the prime number less than 2, 21 is also 2. So here I have the prime numbers less than the approximate square root 8 are 2, 3, 5 and 7. And 72 is exactly divisible by 2, also by 3. So hence it is a composite number. Let me check for the number 47. It is less than 49 and 49 is a perfect square. Square root of 49 is 7. So approximate square root of 47 is less than 7 and all the prime numbers less than 7 are 2, 3, 5. 47 is not divisible by any of these prime numbers. Hence, it is a prime number. Let us check for 39. It is slightly more than 36 and square root of 36 is 6. So the approximate square root of 39 is around 6. And the prime numbers less than 6 are 2, 3 and 5. Here 39 is divisible by 3. And so 39 is a composite number. I again take the case of 47. The digit in the units place is odd. So it is not divisible by 2. The sum of numbers is 4 plus 7 equals 11, which is not divisible by 3. So 47 is not divisible by 3. The digits in the unit place is not 5 or 0. So 47 is not divisible by 5. So it is not divisible by 2. It is not divisible by 3. It is not divisible by 5. Here I have checked with tests of divisibility whether it is divisible by any of the primes less than its approximate square root. So similarly for 39 also I checked for 2, 3 and 5. The digit in the units place is not an even number, so not divisible by 2. But the sum of numbers 3 plus 9 equals 10 equals 12. It is divisible by 3. Hence it is divisible by 3. So as a general rule, all evens are not primes since all are divisible by 2 and 2 is the only even prime number. This includes all the events which ending with 0, they are also not primes. All the numbers ending with 5 are divisible by 5, so they are composite. Any number divisible by 3 you can check with divisibility test if it is prime or composite. Similarly, for larger numbers, you can use the divisibility tests or the square root method just described above to find if the number is prime or composite. Thanks for watching.